What I have here on the screen is a model that at the bottom here, a model that I can blow up, and that is the result of a previous analysis. The model has 5 latent variables, and I have many arrows here that allow me to explore the relationships between these several of these latent variables. Each of these arrows is associated with a beta coefficient and a p-value. And in this case, the analysis was conducted. When I look at settings here, I see that the analysis was conducted using WarpPLS regression, which attempts to identify an S-curve relationship between latent variables, if that exists. If it doesn't exist, then it will default either to a U-curve or a line. Now I will view the form of these relationships. In order to do that, I go to the option View, and then View Plot Linear Relationships among latent variables. And as you can see here, of all of the relationships, only one ended up defaulting to be linear, this one. So when I click there, I can see the plot. I can also save this plot as a JPEG file for inclusion in research reports. Let's take a look at some other relationships. This one has the form of an S-curve. This one has the form of an inverted U-curve with an ending here, which is the beginning of another straight U-curve. The shape in general could be referred to as a distorted S-curve. This one is more like it's almost like a line. This one, again, more like an S-curve. When the nonlinear relationships that best fit the distribution of points are very distorted and very different from a line, this one is more like a line. So when the relationships are very different from a line like this one, typically the path coefficients calculated through warped regression will be higher because they will be reflecting the actual relationship or relationship between the two latent variables.